Hello everyone, my name is Jasjeet, roll number 53. This is a group project made along with my team member Shraddha Suyal, roll number 52. Today I am going to present my project on efficient page replacement algorithm simulator. This project is based on operating system and focuses on how memory is managed using page replacement algorithm. Second problem statement: in modern operating system, memory is limited, but programs require large memory to execute efficiently. To solve this, operating system use virtual memory, where only some parts of a program are loaded into physical memory. However, a major problem occurs when all memory frames are full. A new page needs to be loaded. At this point, the system must decide which page should be removed. This leads to the need for page replacement algorithm, but different algorithm hits or behave differently. Some cause more page faults, some are more efficient than others. The main problem is how to compare and understand which algorithm performs better under the same condition. Objectives of our project are the main objective of this project is to simulate how page replacement algorithm works in the operating system. It helps in understanding the practical knowledge behavior of memory management instead of just theoretical concepts. Another objective is to compare different algorithms like first in first out, list, recently used, and optimal algorithm to see how each of them perform, identifying which algorithm is more efficient among them. The project also aims to calculate page fault and page hits, which are important for measuring system performance. Fewer page faults indicate better efficiency. Additionally, the simulator provides step-by-step visualization of memory allocation, making it easier to understand the complex concepts. Overall, the objective is to improve understanding of operating system memory management in a simple and practical way. Now I want to talk about the algorithm and working of my project. So this is the user interface of our project. So the reference string is the input which we have taken. So I have taken the 7012030423032 as the input. We can set the frame capacity according to our need. I have taken the frame capacity as 3. So now we will execute and run. So I have executed and run the program. So the selected algorithm is LRU. Current request is 7 and replacement is none. Event type is fault. So first of all, the cursor is on the step 1. We can increase the step by next step. So the cursor has increased to step 2, and now we can further increment by clicking the next step button. So the faults are for FIFO, the faults are 10, hits are 3. Hit ratio is 23.1%, fault rate is 76.9%. LRU evicts the page that was used list recently. So the faults are 9 for LRU and hits are 4. And hit ratio is 30.8%. Fault rate is 69.2%. F1 value for LRU is 7 and F2 value is 0 and F3 value is 1. For optimal evicts the page whose next use is farthest away. So the fault for optimal algorithm is 7 and hits is 6. Hit ratio is 46.2%. Fault rate is 53.8%. F1 is 7 and F2 is 0 and F3 is 1 for optimal algorithm. We have traced the LRU decision decoder. Fault page is one uses an empty frame active frame 701. Now we can show the performance. We can see the performance show for first rank 1 is optimal, which have 7 faults and 46.2% hit ratio, and rank 2 is LRU. So on in rank 2 we can use LRU which have 9 faults, 38.8 hit ratio. Rank 3 is 10 faults, FIFO first in first out, 23.1% hit ratio. So the perfect algorithm we can use is optimal, and after that we can use LRU, and after that FIFO can be used to verify the replacement page algorithm simulator. Tools and technologies used in our project. This project uses programming language C++. Data structure we have used are arrays and vectors, queues for first in first out algorithms, map and sets for the list. Recently used concepts used are virtual memory, paging, page replacement algorithm. Platform is web-based simulator deployed online on a platform. Now the conclusion is this project helps us understand how operating system manage memory efficiently. By comparing different algorithms, we can clearly see which algorithm performs better, how page faults affects system performance. It is especially useful for students to visualize complex operating system concept in a simple way.